function is a pairing of ordered pairs where every x is unique. What does unique mean? There's only one. Okay? All the x values are unique. And if we're seeing the graph, that means they pass the vertical line test, which means anywhere you put a vertical line on that graph, you're only touching a vertical line in one place. So here's some examples of some relations. We call it a relation if it's just a set of ordered pairs. So to see if it's a function or not, you're looking for all different x's. It's okay if y is repeated, but your x's have to be all different. So look at this one. I'm looking at the x column. Are any of them the same or are they all different? All right, so this first example is a function because all of my x's are different. They're all unique. There's only one x for each term, okay? So that one is a function. What about this next set of ordered pairs? It's not a function. Why is it not a function? Right, -2 and -2 is the same thing. So this one is not a function. So any questions about determining if something is a function or not a function? So sometimes you might see a function like this. Sometimes you might see it as like just a list of ordered pairs, Sometimes you see it as a list of ordered pairs like that, and you just look for the x's. I like to highlight mine or circle the x's so I can tell if it's a function. And like we said, if it's a graph, you check the vertical line. Okay, do the vertical line test. All right, so what we're going to do is practice finding function values for a linear function. Now, a linear function does what a linear equation does, and that means it makes a line. Okay, so a linear function is just the same as a linear equation, except for instead of y equals mx plus b for slope-intercept, instead of calling it y, we call it f of x. So that f parentheses x means f of x. So a function is like a machine. If you have an equation for a function, it's like a machine. You put something in, you get something out. Okay? So x's are sometimes called inputs. So x's are what you plug into a function. Your f of x is what comes out of the function. I put in x, I get out this. So if you want to think of f of x as y, it's the same thing. You plug in the x, your output is the y. You plug this in, you get this out. So anyway, so if it helps you out, every time you see f of x, you can think of it as y. Okay? So it's just like regular old linear equations, except for instead of y, we use f of x. So y'all, this is a state standard. It is very important. It is tested on the EOC. And this will not be the only time we see this stuff, because we're going to do functions for quadratics, exponentials, and all kinds of things. So it says, what is the value of the function f of x equals 3x minus 5 when x equals 3? Now, how do you think we're going to figure this out? Right. Your function is what you put into the function. Your x is what you put into the function. Okay? Here's my function. I'm going to plug 3 in. So what you're going to do is everywhere there's an x, you're going to put a 3. So this function at the value of 3, so I even put a 3 in right there, f of 3, that means the function when x equals 3, equals 3 times x, and x we said we're plugging in 3, minus 5. You're right, I can't see. I looked at it slanted. Thank you, guys. I just saw the 5. All right. So then we evaluate that. You just keep f of 3. Y'all, this is not f times 3. It's f of 3. Okay? It's just the name. Okay? It's a name. So you're not doing anything mathematical. F is not really a variable. So what is 3 times 3? 9 minus 15 is -6. So this function, when x equals 3, is at -6. So another word to say the y value when x equals 3 is -6 for this line. So that point, 3, -6 is on this line. If if I graphed it with slope-intercept form. So that's what that means. Okay? So all you do, if they tell you x values, you plug them in to get what that function value is. All right? So this one, I believe, yep, asks you to do 3 different function values. So it says, what is f of x equals 2x plus 12? And this time they gave me 3 x values to try, -8, 0, and 2. So what do you think that means we'll have to do? Plug all of them in individually. So that's what you have to do. So first we're plugging in what number for x? So f of -8 equals 2 times -8 plus 12. All right, I'm going to drag down my f of -8 equals, what is 2 times -8? And what's -16 plus 12? -4. So f of -8 equals -4. There's one of my answers. So on that line, when x is -8, the y value is at -4 on that line. Okay? Then I'm going to do the same thing with the other x values. So next we plug in which one? 0 for x. So the function at 0 is 2 times 0 plus 12. Well, what is that? 0 plus 12 is what? So that was nice arithmetic for us. The function when x is 0 is 12. So that line is hitting the point 0, 12. Then we do the same thing at 2. So 2 times 2 plus 12. And then it's 4 plus 12. So this function when x is 2 is what number? 16. So that means that the points -8, -4, 0, 12, and 2, 16 are on that line. Okay? Those are all 3 points that are on that line. Okay? Any questions on that? Okay. Now we're going to find something different. It says, find the value of x so that the function has the given value. So just a second ago, they gave me my x's to plug in, correct? This time they're not giving us x. We have to figure out what x is that makes the function equal to this number. How do you think we do that? Think about it. What? The question is, I'm finding what x is. So I don't plug this in for x because that's what I'm trying to find is x. So this is an x. 6 is not x. 6 is something else. What is 6? It's what you get when you plug in x, right? Right? Essentially, it's the y value you get to the ordered pair. Right? Right? So, if f of x equals this, and f of x equals this, can I set them equal to each other? That's actually the transitive property that I've been talking about in geometry. If two things equal the same thing, then they equal each other. Or you could also think of it as substitution, right? Y'all get that? Like, look, f of x equals 6, that's your y value. And isn't f of x the same thing as y? Yeah. So where they have f of x, I can replace that with a 6 and set up the equation 6 equals 2x minus 10. Okay? So if it tells you f of x equals a number, you're not finding it, you're not given the x, you have to find x, and you put this number where the y would be. Does that make sense? Okay, so how do I solve this for x? Add 10 to each side. What's 6 plus 10? Equals 2x. Then what? Divide by 2 everywhere. What's 16 divided by 2? 8. There it is. So that means the ordered pair, 8, 6, is on that line. Okay? Got it? Because that's the y. So all you're doing is plugging this number. When you have to find x, you plug this number where the y would go. Does that make sense? Or you can think of it, f of x equals that, so I can substitute that where they had f of x. So that's another way you can think about it. All right, so what your book does is they're not so wordy. They do this. And let me find the directions in the book so I can read them verbatim. Y'all know what verbatim means? It means exactly what it says. Okay, here's exactly what your homework assignment says. Find the value of x so that the function has the given value. Okay, so here's my function, g of x. Now, we call this one g, the others have been called f. They can be called whatever variable. Okay, this function is the most, f is the most common one. A lot of times it's g. Sometimes there's a lot of h's, but they really can be any variable. So that's just the name of the function, okay? So g of x equals negative 2x plus 4. So we want to solve for x so that the function equals this value. So they write it with a semicolon. Y'all see that? But it's just like the problem we just worked. So we're going to plug this in the g of x slot and solve it for x. Okay? We're still solving for x. Does that make sense? All right. So 16 equals negative 2x plus 4. So if they give you x, you plug in x. If you're looking for x, you plug it in for the y spot. Does that make sense? Okay, so now how do I solve that for x? Subtract 4 everywhere. What is 16 minus 4? 12 equals negative 2x. And then I do what? Divide by negative 2 everywhere. What's 12 divided by negative 2? And there's my x value. So that means the point negative 16 is on that graph. Okay. I want you guys to try this one. This function is called h. Hi, h. Okay. And there's your semicolon, and there's your number you're plugging in for h of x. So you're still finding x. So try that the same way we just did the last one. Check it with somebody, please. Y'all help me out. What do you do? How do you set it up? 105 equals negative 5x plus 75. Then what? What's 105 minus 75? 30. Please put your library book up. And now what do we do? And what'd y'all get? Negative 6 for x. Are there any questions? All right. So, like I said, if they give you x, you plug x in. If they want you to find x, you plug that in for the function name. Got it? Okay, here's a little side note. What if they want you to tell you a function is f of x equals, I'll make it simple, 2x. And they want you to find f of negative 3. What do you think that means? Right, this is where x was in the name of it, right? So that's when you plug, so they did give you an x. Does that make sense? Because this is the same setup as this, so that's in the x place, so you need to plug it in the x place. Does that make sense? So that's how sometimes they'll ask you to do that. Because I just looked at your assignment and it will, so you'd say f of negative 3 equals negative 6. Does that make sense? So if they have it in parentheses, that means they're giving you that x to plug in. Okay? So if it's in parentheses, that's also giving you the x. All right. We are going to talk a second about some graphs. So if you have a little piece of graph paper you could grab out, just one's plenty. Yeah, you're awesome. That works out good, don't it? Today it does. All right, we have graphed a lot of linear, we call them equations, but they're also linear functions. Same thing, just different notation. Okay, we've graphed a ton of them in the last week or so, including our quiz yesterday. But something we have not talked about is the parent linear function. The parent linear function. Now let's talk about why something would be called a parent function. Brainstorm. Why would you think something would be called a parent function? Very good. He said everything else is kind of based off of it, and that's absolutely true. We have genetic characteristics of our biological parents, right? My daddy was gray-headed at 30. Yeah, me too. Okay? I just can't see it because I go beauty shop like clockwork. All right? I pay lots of money for my color. All right. Okay? My mama has pale skin. I do too. What else? Yes, that comes from my daddy. So we all have stuff from our parents that are physical characteristics, right? Traits that you can see. Things in common you can see. Okay? So, that is also true with graphs. Okay? The parent function is the most basic linear function. A linear function is a base line, right? Linear function is a line. Okay, so the parent linear function is the most basic line you can graph. And it is the equation f of x equals x, or we could call it y equals x. Okay, that is the most basic line. Well, let's graph that line. See what it looks like. It's the most basic one. You should know what it looks like. So I'm going to do that with you. So what's the y-intercept? 0, right? So it's going to cross through the origin. What's the slope of this line? What number's in front of x? So it's 1 over 1, right? The slope is 1 over 1, so you go up 1 to the right 1. And you can do that multiple times. I'm going to do that actually to keep it more accurate. And I am going to use my ruler on this one. So this blue line right here that I'm graphing is the parent linear. Oh, that's terrible. The parent linear function. That's a little better. Close enough. Which is the most basic line that you can have. Okay? The most basic, simplest line you can have. The y-intercept is at the origin. The slope is 1. 1 over 1. Okay? So all lines have similar characteristics as this one. All right? Now, have y'all noticed that some lines have a real gradual slope? Like they're really kind of very not steep. They're almost horizontal and they just kind of slowly go up. Have y'all noticed some things about lines? And have you noticed that some lines are like really steep and they kind of shoot up almost vertical? Right? Do y'all know what makes them that way? Okay, it's their slope, right? Right? It's their slope. Now, actually, you can kind of know how the graph will look just by comparing your equation to your parent linear function. Okay? So this is kind of helpful right here. Y'all know the greater than and less than symbols, right? Okay, that's what those are with those ones. So if you have an equation of a line with the slope is less than 1. Now, y'all, what kind of lines or what kind of slopes are less than 1? And I'm not talking about negatives, because negatives just work the opposite direction. Fractions, are all fractions less than 1? No, improper fractions are not, right? So like 3/4 is less than 1, a half, 1/8, all of those kind of fractions that are less than 1. So any fraction or decimal even that is less than 1 for a slope, it's going to be less steep than that parent function. It's going to be one of those that's just barely going up. It's almost horizontal. It's just slowly going up. Okay? So anything that has a fraction that is smaller than 1 for a slope, it will be less steep than that parent function we just graphed. And along the same lines, if we have a slope that is greater than 1, can fractions be greater than 1? Yes, they're called improper, like 5/2 equals 2.5, right? So improper fractions or any other number that is greater than 1, then you're going to have a steeper line than the parent function. So a slope of 5x is going to be really steep, or a slope of 5 with the x will be really steep. A slope of 1/5 with the x will be really almost flat, right? Just gradually increasing, very slowly. So this is just kind of a little hint to you. So if you're like glancing at a line on like a test and it says, what's the slope of this line? I mean, you might can eliminate answers if it tells you, if it's really flat and it tells you one of the answer choices is 15 for the slope. That's going to be a really steep line, right? So that can help you weed out some stuff. So what we're going to do real quick, and this is the last thing I believe I have for these notes, is we're going to graph two lines separately, but we're going to do them on the same graph as the parent function so we can kind of compare them. Okay? So my first function is f of x equals 3x. So we're going to graph that line and the parent function on the same graph so we can compare them and make sure that what we just stated about those slopes is true. So that's what we're doing. You're just kind of verifying it with a picture. Okay. So I'm just drawing me an x and y axis. And I'm going to graph the parent function in blue. What's the function for the parent function? F of x equals x. Or just y equals x, right? So I'm going to graph that one first. So it starts at 0, 0. And it's up 1 to the right 1. Looks something like that. So there's my parent function. And then I want to graph on top of that same graph, f of x equals 3x. And I'm going to graph it in red. What's the y-intercept for that one? 0, 0. What's the slope of that line? Over 1. So I go up 3 and to the right 1. So I got my red line and my blue line. I'm not hitting that point very good. That's better. A little better anyway. So, compare my slopes. My slope of my red line, is it greater than or less than 1? Greater than. We said that that graph should be more steep than the parent graph. Is that line more steep than the parent one? Yeah, because it's going closer to vertical than the blue line. Right? That's all we're doing is just comparing them, y'all. There's a method to my madness. All right. So we're doing the same thing with the next one. Y'all make a prediction for me. Yeah, it's going to be less steep than the parent function. So let's just prove it with our little graph. I'm going to graph that parent function on there. Slope is 1. It goes through the origin. And it's kind of easy to like graph the parent function because if you can just like line up your little corners of your boxes. My screen needs to be recalibrated because my pen is not hitting where I tell it to hit. All right, so there's my parent function for that one. So for f of x equals 1/3 x, what's the y-intercept? 0. Where does the slope tell me to go? I'm not going down. I'm not going down. It's positive. Up 1 and right 3. So yeah, it's going to fall under that blue line. Something like that. Oh yeah, a lot less steep. So that just helps you compare graphs just by seeing their slopes. If your slope is greater than 1, you're going to have a steeper line. If your slope is less than 1, you're going to have more flat. It won't be flat, but it'll not rise as fast. Got it? Any questions on anything we talked about today? All right. So I've got us some practice ready. You ladies that missed the quiz yesterday, do y'all want to take it in class today? Can you do it? Or you want to do it some other time? Okay. Gotcha. All right. I'm going to try to get y'all a... Actually, can I get y'all to step out so we can go over the quiz? Could y'all go stand in that little cove area and leave? And I'll lock you out, but I'll let you in. So can we go over our quiz real quick, guys, before I write down the assignment? Okay, that's what I want to do. Yeah, you know what you made. My third block class didn't need to get to know what they made because I didn't grade theirs in time. So y'all are special. You just got lucky is what it was. Oh, recording is over.